Hi, good morning, good afternoon, ladies and gentlemen. Welcome to this, the fourth event of the IEEE Computer Society's Software Design Program. We are a recognized project of the World Design Capital, and I'll talk more about design in a few moments. Our previous themes have engaged the themes of community, connectedness, and lifestyle. The core phrase here is that caught my mind was the broken pipeline, where people from our education systems don't seem to make it into industry. In our previous event, Aslam Khan facilitated a most interesting roundtable discussion with Phil Koopman, Dr. Brain, and Lorraine Steyn. One of the core ideas that came out of this. Today we are indeed considering education, but specifically teaching programs at schools. My name is David Hislop. I'm the chair of the IEEE Computer Society. I'll be asking Alan to do formal introductions in a few minutes' time. Alan will take about 20 minutes to introduce the topic, and at the end of that we'll open the floor to discussions. The IEEE is the largest professional organization in the world. In South Africa we have over 1,000 members. The IEEE in South Africa is seeking to position itself as an independent, authoritative, technical organization. In preparation for this event, I did a survey on approaches around teaching software related issues at school and at universities. And there doesn't indeed appear to be a massive amount of methodology around it. In fact, there's so much so that I couldn't possibly hope to even begin to understand it. And I'm really hoping that there's people in the audience who are able to address us with regards to, for example, issues such as the ACM's K-12 program. Alan Ribich was the obvious choice to facilitate this event, not only because he successfully addressed the Department of Basic Education, or that he's right with his belief with regard to Java or not, but what Alan achieved was quite remarkable, was that he actually managed to get software engineers and programmers and developers to cooperate and collaborate, which is truly phenomenal thing in its own right. Instead, I briefly mentioned design. Design thinking appeals to me because it seeks out the end result rather than solving problems, which as scientists and engineers and programmers do. So we're quite good at finding solutions to problems, but not so good at thinking about things in the broader context. Software is almost a canonical design discipline. It's not about pretty user interfaces. I'd like to quote three people in this regard. The first is Wesley Depoko, who said, social media is a distraction. We should develop software to address our needs. Phil Koopman said, the problem about software is that we need to make other people, that we make other people's dreams ours. And finally, Aslam Khan said, we are software consumers and not producers. Which is quite a sad thing to say. In this regard, addressing teaching programs at school fits the cornerstone of planning for success. Planning to empower people to develop useful software and to take ownership of our software problems. Alan, would you like to take it from here? Sure. Thank you.
Okay, so I'd firstly just like to would like to put forward a quick welcome note first. I'd just like to extend a special welcome to the members of local and national government, primary, secondary and tertiary education institutions, industry representatives and all other parties present. I'd also like to welcome everyone that's online, because we actually are not only recording this session, but we are trying to stream this session live to our other members that cannot attend this event today. Okay. So without further ado, what I'd like to do is I've put together some slides together just to get a bit of an overview of some of my thoughts and some of the things that are going on at the moment, not only in South Africa but beyond the borders. And So without further ado, let's just jump in straight into that. So importance of computer literacy in the 21st century. So let's start off with the definition very quickly. So Oxford English, the English Oxford Dictionary reads as follows: having sufficient knowledge and skill to be able to use computers and being familiar with the operation of computers. Now, if you do some search on the net, you realize very quickly this is a very much of a changing term in terms of what computer literacy means today. Some like to take into terms such as basically learning, learning a new skill and computational thinking and those sorts of things. Computer literacy is still very much in the hands of the elite. Why is that the case? Because we will see from the statistics, we still got quite a way to get the necessary widespread. The importance of computer literacy, obviously the computer literacy and education needs to play a very important bridge between, to obviously bridge the digital divide. And the internet for knowledge acquisition is very much a commonplace today in the developed worlds, whereas in a developing nation such as South Africa, we still have a way to go. So when I say knowledge acquisition using internet, you can think of something like, let's say, really is a great online platform by which students can learn a range of subjects and at different levels, such as computing, maths, science, and so forth. Now, the actual proportion of households with computers in South Africa has increased from 8.5% to 21.4% between 2001 and 2011. This is as per the Stats SA census 2011. The population itself who actually have access to the internet has also grown. 2009, internet is not only through computers, but it's mobile devices and so forth as well. And not just in households, but it's at work, it might be at any other institutions. The bottom line is, it does look like a good number, but we still have a 60+% of people with no access to internet whatsoever in this country. Now, finally here, 53% of schools have at least one computer, but only about 15% actually have access to the internet. And this is per 2009 results, again, from Stats SA, focusing on the research on schools. So, there's quite a way to go in that particular space. So let's look at the importance of learning to code at a young age. I beg the question, if literacy is mandatory in early stages of childhood's life, in the digital age, shouldn't computer literacy be mandatory too? So, if we look at going from computer literate to code literate, so what do I mean by code literate? I mean someone that can actually program. You can think of it as programming literate, okay? And what is it? It means as a person, as being illiterate would be that could read and write. This really means being able to read and write in the context of programming languages itself. One second, please. Yeah, exactly.
Check the time.
Okay, one second.
Please get a Windows machine.
Aha! There we go. Or maybe more accurately, I think this projector is made for Windows environments. Good. Okay, so back to it. Why am I talking about code literacy? Because if we are to encourage young people to become creators of technology rather than just consumers, it is a very vital part of the education. They have to learn, number one, first, there are two very important skills. Number one, to think computationally. Okay? So how do I take a problem and translate that into computational terms? That's really important. Okay. And then secondly, teach them how to then be able to actually build things that can execute and be automated for computers. That's it. Now, I'm not sure if many of you know, but in September of 2014, United Kingdom will launch a mandatory computer syllabus for students ages between 5 and 16. Okay, that's quite a big jump. It takes in, from very, very early stages. And this, I think, communicates back to my other 2 points. I think it's very important. I will touch on this particular part. What is the right age to engage in a second. Now, a small detour. Small form factor computers, also sometimes known as credit card computers. You've seen your Raspberry Pis, Arduinos, and so forth. These computers are seriously on the rise at the moment. What's so nice about them? They have decent power to be able to provide the most basic things that a student would need. But they're also very cost effective. All right? So, as I said, as a child, I used to play Legos, and that's fantastic. But being able to program can really be fun. And here are some of the ways. There's for instance, a bunch of guys have recently built this thing called Kano. And the idea really is it's a small pack of peripherals and basically, these small form factor computer that comes with it. It retails somewhere around, in rand terms, around 1,000 rand or so. The bottom line is it comes with a manual and you can assemble it literally within like 2 minutes. Okay? The great thing about devices as such is that it may provide the necessary reach in our country to give the computing habit in the past. Now, on the local front, there are some very good developments going on at the moment. As a matter of fact, one of them that I can speak off the top of my head is the developers of EduCube. I'm not too sure if anybody's familiar. But EduCube has been developed, also being a small form factor computers, these smaller computers. And the idea really is that they can basically, what they've done is they've loaded offline Wikipedia into these devices. And what they've done further with that is they've put on the past educational papers. I'm saying examination papers and so forth. So what they're really doing is they're saying, well, we understand that challenge you just showed me a couple of minutes ago with regards to the internet challenges, being quite low. That we still, there still isn't enough reach there. But we can at least start doing this by placing by giving these small computers, getting them out there into far reaches of South Africa. Okay, so, and I think on the local front, firstly, they definitely need the support. We need to support these kind of initiatives. And so that's basically a very important point there, is that there's some really, I think, great opportunity that comes out with these sorts of innovations that have come by already recently. So, what is the right age to engage? That's a very good question. So Vietnam, Estonia, and now United Kingdom, as a matter of fact, have a much more programmer-centric curriculum as part of the early computing education. So a guy by the name of, just recently, a guy by the name of Neil Fraser from Google, who works in the education department of Google, went out to Vietnam to actually have a look at what basically, because obviously he's heard there's interesting things going on in Vietnam in terms of their curriculum and that. So he said he wanted to go have a look at hands-on of exactly how they teach the subjects, and how is this received by students, and how far have they progressed. So by grade 4, Vietnamese students start programming in Logo, similar to Scratch and those kind of much more educational type of centric languages. So what they then also find is that they start with sequences of commands, and then move on to processing, and move on to constructs such as loops and so forth. Okay. What's really where it gets even more exciting is that in the 5th graders, is from his own assessment in Vietnam, are actually so skilled that they concur as well as 11th graders in the USA. But for me, the one that sticks out the most is the 11th graders in Vietnam, from his assessment, can actually take the Google interview process and pass it successfully. I'm not too sure of how many of you over here in the room know what the Google examination process is like. I have been through it, and I'd like to share the details. It is very hard. It's technically very challenging, and according to Neil, they can take that exam and pass it successfully. So it's remarkable. So why is this remarkable? What does this speak to? This speaks to that I think that we need to start looking at, yes, we're going to get into details just now about the high school curriculum and all that. That's wonderful. But I think we need to take a step back and say, hang on a second, should we not be looking at a formal introduction of curriculum early enough in education in South Africa? This is happening around the world. And I certainly think we should. Let's look at this further. United Kingdom curriculum. The actual subject content of Key Stage 1, the Key Stage 1 is really what they call the ages between 5 and 7, has the following subjects. And understanding what algorithms are, firstly understanding what it is before you actually try to do things algorithmically. But just take note of the age, so just we're all on the same page. Creating and debugging simple programs. Using logical reasoning to predict the behavior of simple programs. Using technology purposefully to work with digital content. Using technology safely and respectfully. And finally, recognizing the common uses of information technology beyond schools. Now, I think that this particular last point is one of the most important, vital points when it comes down to computing education. Why is that the case? And here it is, because if we are to encourage young people, like I said earlier, to become creators of technology, that doesn't necessarily happen in classroom. Yes, you learn a lot of important skills and vital skills in classroom. But out of class, it's equally, and if not more important, to be able to recognize this beautiful country we live in that has a number of important challenges and be able to solve them. You see? So that's why I say it's great to have the syllabus, but it's important that it encourages going out there and working on things yourself. Okay? So what are some of the important elements when it comes down to now programming languages and basic education? So let's look at this firstly. Let's group them into two groups of programming languages for the sake of this talk. We have the educational programming languages, and we have the general purpose programming languages. So by educational, as its name states, it's very much a single purpose design programming language for teaching purposes. There's certainly a place for that. The question is at what particular level, and where does general purpose type of a programming language come into effect? So maybe just to explain a bit further, what is a general purpose language? It's a language that really allows you to work on multi-purpose, it's a multi-purpose, and allows you to work on multiple application domains. It's applicable to multiple domains. So it might be working on SKA, or might that be working on some financial systems or some interesting things in the business space? It's applicable. Okay, so for the sake of this talk and the forthcoming discussion, I'd like us to focus on the secondary school from this particular point, which is basically grades 10, 11, and 12. And the general purpose programming languages itself. Okay. So just very quickly, small overview. The most basic elements of programming languages, just quick for 2 seconds. It's primitives, means of combination, means of abstraction. What does this mean? The means of the primitives. The back thing. So primitives. The primitives basically are basically a set of basic data types and built-in operations. Whereas the means of combination is like asking the question is, what is the way to combine these primitive types and operations? And then the means of abstraction really is the is the question of what are the means of being able to hide away the complexity of sequence of instructions to a computer. Why? It enables basically the it enables the attainable and very much usable from that perspective. Okay, but then what are some of the very important characteristics? I'd like to focus on some of these, but there are more. Obviously, there are more than these. But I think these are some of the very important things to take into consideration when thinking about general purpose languages. Simplicity, readability, which means obviously relation to pseudocode, portability, the expressive power. So in other words, what does it take for me to express myself in a programming language to instruct a computer to do something? Do I have to do this very ceremonious process to basically print something to a screen? Or can I just basically say it in the most simplest terms? Or what is it exactly I'm trying to accomplish? And I/O handling, in other words, what is a clear way to handle effectful type of operations? Operations effectful by effectful meaning things that really interact with the real world. Printing to a screen, receiving input from a user, etc. Okay. Now, the Department of Basic Education has reopened the programming language debate. And the need for standardizing on a single programming language has been long debated. And it does seem to be seems to have a general acceptance. So I think there still might be some arguments in this and that, but I think it's come to a point where, from at least curriculum perspective, it makes it easier to be able to examine it and so forth. It does not necessarily mean that practically it's the best possible thing to do, but there's some form of consensus has already been reached, and that's just what it now pretty much is. So, now, the following languages have been put forward for evaluation, and I have been told that this list is being narrowed down pretty quickly. So, so maybe it is important to reflect on the previous slide, like some of the characteristics we spoke about, like portability, readability, simplicity, expressive power, and all of those things. So, and I think that these languages in general, most of these fit that pretty well, but some better than others, of course. And some of these languages, as I'd say, are as what they call statically typed, others are dynamically typed. And the question is, what is better in the context of education? That's a really good question. The bottom line is the evaluation process is currently kicking off. My part is where I would love input from different stakeholders is to find, I've defined some of these elements, but it's to narrow that down to what really makes a better fit. So if we're talking about standardization, since that seems to be the case, then what is the best fit? Okay. And then just some final points. So, like I mentioned, we do live in a country that has plenty of unique and interesting challenges, let's face it. So, we definitely need to teach students to become creators of technology and not just the consumers. That's the bottom line. My wife and I, we have a 5-year-old daughter, and since she was 1, and I'm sure many here can reflect, she could use an iPad, an iPhone, and at this particular moment, she's become somewhat of an expert. But as a consumer of technology, and that's a really good step. As I said, for basically a 5-year-old, that's great. But what's the next step in this? And that's a question I ask now as a father. So I'm putting myself in the different shoes here. What is the next step? There's plenty of these interesting challenges. She looks at them. She might think about them. But can she maybe try to model these computationally and try to, be able to actually create them to allow other people to use to solve interesting problems? So what do we need to do? So I believe that all students in schools need some form of early exposure to computational thinking and code literacy. So it might sound like a bit of an ideal, of course, but I believe with some of the points I've covered here today, it certainly is an achievable task. probably not an easy one, but something that I believe that should happen. So we need to bring that formal part of education. Yeah.
I'll only just comment, so I'm not entirely sure what you have covered.
Shoot. Yeah.
I feel the same, and I feel that a good standpoint to start from is teaching pure logic.
Maybe not formal, you're saying, but I'm saying when you say logic, you're talking like first order logic and those sorts of things? Okay.
Because at the moment we teach mathematics at school, so but what happens is the focus happens on the computation, and people don't need to do computation, they need to learn to think logically.
Yeah. So that's the part we do cover, is the computational thinking part. So when we speak about programming languages here today, we say, oh, teach you to program in school, that's fantastic. But it has to work hand in hand. As a matter of fact, there is almost a step before, and that is computational thinking that you're referring to. The logic part, and then how do I take this problem that I know, that I learned how to solve, translate that into computational terms. And then, yes, programming then becomes a means to be able to instruct the computer, write the necessary program to instruct the computer to do something. So, but yeah, it's well pointed out. And just lastly here, the right CS, IT, and I intentionally use the word here CS, not CAT or anything like that. I do it because I believe that some of the computer science aspects can be taught very early. The curriculum is paramount to the future of innovation in South Africa. It really is. And this is the thing I say, is because if we only look at it from a perspective of, okay, we introduce it in grade 10, 11, 12. If you catch on at that particular point, sure, you're probably pretty well lined up for tertiary education and all that from a computing perspective. But there's so much more time. As I've shown earlier, in countries like in Vietnam, what's happening now is going to be happening in UK, Estonia, start. That by the time they hit grade 12, you could probably look at something like Malcolm Gladwell's perspective and say 10,000 hours of getting the experience. You pretty much get so much experience by the time you reach matric. And I'm just trying to really encourage that particular thinking, is to start thinking early. Let's speak to the necessary stakeholders to see what will it take to introduce a formal curriculum in the early stages of childhood's life. Okay, so that's as far as that goes. I'd like to maybe just bring up, try and bring up a bit of a discussion going here from this particular point. I do have some questions on hand as well, which I can, of course, refer to. But at the same time, we've heard what I've had to say today so far in my, presentation. I'd love to hear any sort of a feedback, any sort of a thinking from different stakeholders of what the success factors are, and what should we be honestly be striving. Maybe firstly, immediate, as an immediate thing, to look at the curriculum, the CAT curriculum, but also beyond that, as I described today. So I'm not too sure if there are any interesting things that people would like to share. Maybe, as I say, as a starting point, of what has maybe worked in the current sort of education space. That I'd like to keep open to primary schools and different levels and that. So if there's anything, otherwise I'll of course bring up some maybe questions that I do myself have.
So what I'd like to do is, I'd like, if you've got a point to make, would you please identify yourself so I know who you are, and I'll endeavour to try and record your views so that we can actually try and get them together. And if you could please make a statement about what you're doing. And I'm afraid to say we don't have time for an argument at this particular point about the pro and cons of Java.
Yeah, but as I said, we still have, thank you, David, we do have some time, and the idea really is to, let's bring it out in this forum. It's important, because if we do, as I said, it's very much, as I say, I've taken, up on myself to take these things and actually do something about it. I have, like before we mentioned, is that I have personally had successes with meeting with Deputy Minister, meeting with the necessary people in Pretoria. By the way, so everybody knows, I am based in Johannesburg. So Pretoria is just a quick ride away from me to jump in and speak to the right people. And I think from our previous exercise last year, with regards to at least the process of stopping the standardization process for the time being, which occurred, has been success. And I think we can continue on that theme. And I vouch for that I will do my part. But I need the input, and I need the different stakeholders to come to the party, so to speak. Yes. David.
Dave Weaver, I'm a technologist, engineer, and these days entrepreneur, amongst other things.
PhD.
Yeah, somebody wrote that there. I think you touched on this thing a little earlier, the British are doing. They're looking at some things, we're talking about understanding the purpose of an algorithm and predicting its outcome. This is music to somebody like my ears. I've been doing this business for, these things are here in my bones. As soon as somebody brings up a computer programming language and they start talking about that, the entire debate goes completely and utterly haywire because you're forgetting about what you're trying to teach. I don't care at the end of the day what computer programming language somebody walks in with. I care that they understand the system well enough that they can flip languages and learn a new one inside of 2 weeks. Okay, so really, I know people get into these big holy wars and people carry the stick for Java or C# or whatever the hell. We need to get into a world where we don't care about this anymore. Okay, and that is starting out the way we're approaching it in one of my endeavors is to make sure that people learn multiple languages in the process, simply because it's part of that. You have to know about statically typed languages. If you do not know about statically typed languages, you're technically illiterate. You need to know why it is like that. You need to be able to use dynamically typed languages and understand what their purpose in life is. And you do this basically by using both languages and understanding what they're trying to achieve. So whatever inputs I've been putting in here, it will be driving back to the basics. How do linked lists work? Why they're important? How do we apply them in the middle?
Yeah, good point. Thanks, David. That's spot on. Good stuff. Yes, please. Sorry.
Right, question
please.
So in your view, what makes a good programming language in today's 10 and 12? As policymakers, what should we look at in selecting language? And the second question is related to the question the gentleman asked today. In your view, is it appropriate to expose grades 10, 11, and 12 to multiple languages that early?
So yeah, I'll try to answer that, and I'd like also to keep the floor open for some of the other members to particular view. I do think that there is no silver bullet language. I believe. So there's no, you can say here it is, it's Java. That's why we're looking at anything else. There's no such thing in my own personal opinion. Okay, what I do believe is one needs to firstly evaluate and actually say, well, when you start from grade 10. What previous experience have you had? So you see what I'm doing over here? I'm asking the question, what previous computing education experience do you have before you enter the space? So if you tell me, for example, a language that's very powerful, for instance, it might be very powerful, but is it the good entry starting point for, let's say, grade 10? That would be the question to ask. So what's my answer there? My answer would be to look at these different attributes, some of these challenges I just named one, and actually say which one actually fits the bill the best. So yes, of course, this is still, and this is what David and I think other David here also agrees on that, is that we have this issue of as soon as it becomes a language thing, it's like a war thing. Like mine's better than yours. It shouldn't be about that, and it does become difficult because you are speaking about a single language again, and it's not perfect. So there are going to be flaws in it. So you're immediately going to be sitting in this boat where, well, it's not perfect, but then what is? Well, there isn't anything, so which one do we choose? Basically, I'm saying back to you, it's actually really tough to choose on one. If it was up to me, and I had to say, what route do you take? I would take a route more of a idealizing. It would be on the basis of actually not standardizing on a language. That's my personal opinion. There we go.
Just to your point, they actually do learn two languages. I have a kid who's just finishing up matric now. The first one is Scratch, okay, which is beaten to death. I think to teach grade 8s or grade 9s is, you know, if you probably give it too much. And then they go over to Java. So it's quite possible. I don't believe there's any fundamental reason.
So you were next. You still have a question?
Yeah, it's a little bit on a different point. There's the
again?
Going back to the beginning, not all people can do mathematics. We go to mathematics literacy. Not all people can program. We look at things like, say, Malcolm way back, or Worthington Smith, or any of these things. What percentage of people who actually want to program do have the ability? I have a slight fear if this is forced down, the kids will say, we'll have computer literacy like we have mathematical literacy. Not everybody in school can do it.
Oh, it's a good point. It's just it comes back to this thing of computational thinking first. Okay? So let's get that out of the way. So you'll say, well, how do I sort of think firstly logically and translate that? But then from a programming perspective, I'd like to challenge that maybe just on one part, a person, and just say that there are programming languages that certainly are a lot easier to learn than others. Okay, so why am I saying this to you? I'm saying it because if you look at it right now, you might say, okay, well, Delphi or Java. I personally like to say that yes, those languages can be taught, sure. But there might be an easier way. You know, I know for a fact that there are easier languages that you can use that can give you potentially a lot more exposure, you know, because let's be honest, firstly, a lot of young people do like to work on things. They like to work on also potentially fun things, you know. But how do we basically solve it? So as you're saying, well, if the tools are hard, then you can't. So I mean, it's going to push a lot of people away. So I agree with you on that, but I think the challenge is, firstly to bring in the right thinking, and then to bring in the languages that are easy enough for, of course, the level you're in. You know what I mean? So you see, that's why it's not a one-fits-all. I'm sorry, like I've got a Java background of about 12 years. I like to call myself a professional in the language that I know inside the virtual machine and those kind of things. It's fun to be an old daughter to start learning to program in Java necessarily. And I'm by no means picking on Java. As I said, I like the language. But is it the right tool? See?
I would say yes.
It is? Okay, no, I asked the question. Yeah, please. Yeah.
My name is Chad, and I've been doing software engineering for about 7 or 8 years now.
Sure.
So I've switched through a lot of different languages, from different paradigms, functional, object-oriented. What is nice about the object-oriented paradigm is that it's easy to model our world.
Yep.
So it's easy to understand. And the depth of the features of Java that it provides, it holds all of it. So if you learn this language and you understand, if you understand the concepts within it, then it works.
Please.
I'd go from a perspective immediately. I mean, I also like guess the two of you got years and years of Java behind me. You know, but I can go and point huge big holes in Java. It's an old language. It's creaky. It's just recently, we've got a few things. Yeah, but
that's still something stable.
True, but the point is,
I
we've landed on the point where you're arguing for a language rather than arguing for a set of concepts which have to be taught. We will find languages which map onto every single one of those things.
Absolutely.
Very, very important things.
Please.
Hi, I'm Melody and I'm a consumer. So I work, well, my company makes explainer videos that explain concepts, products, and ideas. And so I'm very interested in education, and I think this is really important for everybody, and that's why I'm here. So you guys are geeking out hard right now, which is awesome, and I'm actually finding it so interesting. I kind of have 2 questions. First of all, look, the language thing, I kind of have an idea. My brother's a software programmer, but I personally don't know much about it. But is that really the challenge that we face in South Africa, to decide which language to teach? I mean,
no.
Okay.
It's more of a, I'm trying to to find the right analogy, but you know, it's like a type of a thing where there would be a lot of, it isn't a simple, oh, that's obviously the right answer.
Yeah.
See the thing.
Yes, I totally get it. So I think, yes, I think the language is close to all the programs and all the, you know, like hard tech guys, I think it's close to all heights. But I'm kind of looking at this from an educational perspective, and it's like, well, how are we going to make this work in our country? And of course, the first challenge is, well, how on earth are we going to get every child in this country from a computer? So then my question to you as geeks, well, the IT geeks, I'm a video geek, is cell phones. Is that realistic? Can we use cell phones to teach programming in schools?
It's a good question. It's a really good question.
So, welcome, Elodie. I think the problem really is that programming in South Africa is an activity of white males. And we've already got a problem out there before we even take the next step forward. I think that the balance needs to be struck. And I'm slightly schizophrenic in this issue that sometimes I feel that C++ is the best thing to teach people, the basics. On the other hand, I think it's the kind of Wayne Gretzky thing as you go after the puck. It's going to be, not where it is. You teach people Scala rather than Java, because Scala is the future. But I think the fundamental balance that needs to be struck, and it's critical in my mind, is that when people leave schools, they must be able to program. End of the story. All the theoretical underpinnings about programming are all well and good, but ultimately people need to be able to program before they can actually start making an intervention in a broader society. And it might sound like a harsh point of view, but if you look at things like maths, and then there's the International Maths Olympiad in UCT at the moment. If you can't do maths, you can't compete at the ILO. The same is true with regard to accounting. Accounting there's a lot of theoretical things around accounting, but ultimately the accounting will be able to need to balance your whatever you need to balance at the end of the day. Something or other. So the balance with this. Yes, you can't be an IT professional and not be able to program. At least at some level. But the broader context is as important, or perhaps even more important, is that are we solving the problems which are relevant in the society? We're not. You're kind of getting this kind of entrepreneurial, breathless, being the next Facebook and so forth. It's actually destructive. We've got issues in this society we need to solve, we're not addressing the issues. And some of the issues are not best addressed by hardcore technicians. They're actually addressed on a perhaps, dare I say, a softer level or a more business analyst level. Or software is not about coding. There's a much broader picture. And if you get mesmerized by the coding, you get into trouble. But yes, you need to code. When people leave school, they must be able to code. Otherwise, they don't buy chips at the table.
Yes.
My name is Morgan. I'm an engineering student at Stanford University, home of some of these languages and companies we're talking about. I'm here working on a project to develop a computer technology center at a school in Parkwood in the southern suburbs of Cape Town. And so very interested in your question, because that's what I'm kind of struggling with at the moment is there are computers at this school. They were a recipient of computers through the Cognium project that provided labs to a lot of schools in Cape Town. So they are, as part of that 53%, with at least one computer, so they have some sort of access. But it's so underfunded. There was no maintenance plan. So really, the computers are unusable. The lab is unusable. They might as well not have access. I'm here designing a new center, trying to fundraise for it, but struggling a lot just because they do have some form of access. It's just not sufficient to learn coding, but even basic word processing in Excel. So I guess my question to you or the audience is kind of relates back: is kind of a traditional computer lab the way to go? And if that is, how are we possibly going to expand that on a larger scale to communities that really don't have any access, not even an internet cafe, down the street that people can use. And teachers as well, who aren't computer literate in any sense of the definition.
Which is that exactly.
Yeah.
Another challenge. Yeah, it's a really good question. Have you, David?
I caused offense at a recent meeting, so I asked the same question, and they said, and I started programming in my computer, Commodore 64, which is about 10,000 times inferior to somehow we got mesmerized by Outlook screens. Actually, about 20 now. And I don't accept the fact that the other computing can't get a basic compiler going. There's such a candidate.
Case in point is the Raspberry Pi that was mentioned earlier.
Yeah.
Okay, you can get someone
Yeah, and there's local developments just on top. I was going to touch on that. Yeah, David?
I priced on a little box 500 rand. You need a keyboard and a mouse to go with it, which you get for about 150 odd rand for a wireless keyboard and mouse. It plugs into the family television, okay, and I think there's space to put a USB data thing if you really need data.
That's what it is, yeah.
Effectively, you have the most popular operating system on the planet and running on this machine. And you can do all of this kind of development on this tiny little box, and it costs 550.
So that's really a really good point. And I mean, these things have been designed for the purpose of, for example, when you say what's the output, so you say, well, it's your television at home. It supports HDMI and the VGA as well. Why? Because they're very well aware that this the use of this is not just in prominent areas or something, but yeah.
But what happens when a person doesn't even have access to write a Word document, to send a resume, like on a more basic computer literacy level?
The computer literacy level is a whole other story. Okay, it's I don't know whether we want to really debate that, but this is just providing. When you ask what provides a platform, this provides a platform. It's not the greatest platform in the world, but damn it, it's 1,000 times better than what I learned to program. So yeah, it's an awesome thing.
I think in communities like that, you just want to find out how large as it was in us, we want to find out, is there really this demand for that sort of thing, and how big is that demand, and then what from there take, it can be worked out, it is possible.
So Peter Barker from the Computer Olympiad. For 30 years we've been running a Computer Olympiad with 3,500 participants every year without specifying language.
There you go.
You don't need to specify language in order for someone to do a practical exam.
That's my view.
We also run something called the Talent Search, where we have about 32,000 participants every year. And I'm afraid that before, and it is computational thinking, because in many of our schools, the learners just cannot think about it.
That's it. That's a very good point.
Thank you. So to add to that idea of logical thinking, I find the reason why they can't think is because they get turned away from mathematics. And they enjoy mathematics to a certain point, and then they stop enjoying it. And that's why a lot of people are crossing over to math literacy.
Yeah.
And math literacy is a good direction. It's a good start. I do believe that it can work. But you need to find the more abstract ideas and logic that we can teach to younger generations so that they can learn to think of them. Because it doesn't take maths to understand things.
Yeah.
It does in a different scope.
Sure.
But not everybody likes maths.
Yeah.
Got another question?
Sure.
So my question is it true? I think that one of the questions earlier was that some people just can't program. So my question is based on international research, is that true? Are there people that just don't understand how to program? And the reason I ask is my understanding of programming languages don't speak English. And Latin is more structured than English, and computer language is a little bit more structured than Latin.
Mm-hmm.
How would then assume that you could speak English and you could give out a better structure, you should be able to program. So the question is based on some research, and I think that's really important as not sort of our view. I'm really interested to know whether we know that there are people that just can't program.
So one, taking from what you said about how different languages are, programming should be easier than English. And the reason for that is because there's no ambiguity. Whereas in English, there's so much ambiguity. And if people can understand the complexity of English, why would they not be able to understand something as simple as a program?
Okay, good. David?
I have a friend who's got a theory that relates to why there are so many Indian programs. And his theory goes along the lines, there's no research for this, by the way, he made it up himself, but he talks about Hindi being a language that is conducive to programming thought. And he continues with that line of thought, and he says that isiXhosa and other languages of that nature have the same language structures that make programming thought useful. Now, I'm not trying to defend that point of view at all. I think maybe I made up that it's just a factoid when you're sober or not. The reason why I'm casting aspersions on the question is that I think that we create an environment that we alienate potential programmers from the environment without any further ado. So what is a heavenly case for male programmers, women programmers find complete alienating environment. I think that we shouldn't ask the question that you wish to ask. I think we should try and ask the question, what do we need to do to find our way through all these obstacles so that people can program? And yes, I agree that far above with one program. But I think that we aren't fundamentally making the field open enough that we can even begin to address that question in a vaguely scientific or fair way. It actually obscures the question. I don't think it's a good question. I think the question is we actually need to pursue the issue of making the programming environment more conducive to people doing it, and then look at the second order or third order questions about whether people can in fact program.
Yeah.
I think also that in the context of education, people have different strengths and weaknesses, right? I'm going to have natural strengths, which hopefully I'll develop in life, and probably within those strengths I'm going to be, finding life fulfillment, my calling, whatever else. And the job of education, certainly primary and secondary education, in my opinion, is to expose the children to enough variety and a reasonable standard of that, so that everyone is able to partake, if you will, at least to a certain point, at which point they then specialise, which already have built into the way that such choices happen and so forth. But I should be exposed to a bit of everything. I think that's valuable and important, even if it's difficult for me. I was exposed to science, hated it, but it was a good thing for me to be exposed to it. Nonetheless, to a certain point, at which point I can then decide to follow a different course. But I think being exposed to a certain degree is important for everyone, but also recognising that the context of people, research, I think, would probably back me up and say, well, we naturally have different strengths. Somebody's naturally going to be good at programming, pick it up, enjoy it. Others are going to drag themselves through the product to a degree. That's a good thing, I think. But to try and say that everyone can be, I am never going to program like the people I work with. And that's okay. It's not my passion enough, and that's okay. But should I be expected to learn logic and program maybe to a certain degree? So
Sure.
Find out if it's my passion? Absolutely.
So this is exactly a very, very important point. The idea is not to bring out industry programmers, software engineers. The idea is, to relate back to my slides, is to bring out people, in order to be able to think about problems computationally, and then be able to some degree, be able to translate their thoughts into something that can run. So again, I'm not saying a software engineer, we know very well, is a far beyond subject than just what we're talking about that should be taught in schools. So, yes.
Tiffany Williams, and I'm currently in my third year at UCT. I'm studying information systems. And I just like to agree with your point, because for me, I only discovered that this is what I wanted to do when I reached my first year at UCT. And I think, if I was given the opportunity in school, it would have changed a lot, because now ECT, I think, they try and fit so much into the 3 years of this degree, and I think there's not enough time. And I feel like I actually want more time, because like I'm not learning everything that I actually want to learn. And I think that if you enter into university with that background already, then it gives so much more time for you to learn further and to further your knowledge and to go deeper into what is the program. So that's just what I feel and what I'm thinking.
Okay. Thanks for that. Yeah, this is great. Yeah, please.
I'm Max Rock, Curriculum Advisor for IT with the Western Cape Education Department. I think some of the speakers have hit the nail on the head. We need earlier exposure to expose everybody. In IT, computers, we need it so that people develop. Why do some section of our population fare that much worse in mathematics? I think it's because they're none or very poor teaching in their early childhood development. And now, I wouldn't speak of bad teaching in IT side. It's probably none. No exposure. You know, and that's why some people would struggle with the program. And we definitely need that. Professionally, I'm looking only at grade 10 to 12. That's my job. That's what I'm employed to. However, I wish there was some form before, because we would have people with informed decisions to choose the subject or not to choose it. So we sit with people that have misconceptions every year and they drop out or fare badly in the matric, and others who didn't choose it although they should have, and they've taken it at university and still managed to blossom. That's not the problem. But at least 3 years more than currently, i.e. starting in grade 6, no, 7 would be nice, but another 3 years before, just on a sort of, you know, very plain level would be invaluable.
Absolutely, that's good. Thanks for that.
What is the line? Sorry, I'm so sorry to just shout out, but what is the likelihood? I mean, you're probably the best person to tell us.
Yes and no. I'm not it's what I would wish. In the arts, they have recognized, I remember when the new curriculum was introduced, there was a sort of core curriculum for what they call arts and culture. They tried to implement it uniformly all over. A bit of dance, a bit of music, a bit of art, and a bit of this and that. And they realized that the potential of the teachers just did not fit that profile. So they made it more modular. They said, if the school has a strong music department, they will drama, but they don't all have to offer everything. Now I wish they have a subject called technology, which I've taught when I was still at school. And it is it's applied sciences, physics, you know, very, very basic. And I think they could cut that out and make it modular. Again, in the first instance, modular, namely the schools that have got the capacity to teach computers and some programming and offer that. They don't have to do all, you know, there would be a space to put more computing into school if that opening was used, because otherwise the curriculum is already over congested. You can't introduce yet another subject. That will never work.
One point I want to bring up, we've taken rather seriously in the institution we're busy setting up right now, is the availability of teachers. Okay. Now, it turns out there's not that many teachers around the place. But it also turns out there's some extraordinarily good ones who make their tools available on the internet. Okay, I speak as someone who has, I'm really an engineer, I'm not a computer scientist, but I function these days as a computer scientist, having learned pretty much everything out of books, sometimes courses on the internet. The knee-jerk reaction when somebody comes to me and says, how do I do that? I go scratch around until I find the right thing on the internet and figure it out from there. And I think what we could do to really alleviate a lot of the problems we're having with the teachers themselves, not being able to skill themselves up, is to actually teach students to go and look outwards. Now, I know there's a lot of problems, internet access and all of these kinds of things, but there is a place to go and look. Today, I don't know any programmer who does not actually do their job without Stack Overflow sitting open right there. You know, we do online courses. There are fantastic training tools out there that are literally there for the taking. So we can turn ourselves into very, very powerful learning machines by just developing the ability to go find the information for ourselves.
Okay, good point. Yeah, one last one.
In terms of your ultimate goal of introducing computational literacy as a I guess the difference between us and the UK is, I mean, there are differences. We know that we have weaknesses in maths, for example. Chad was saying a lot of people seem to fall off the bus early because of weakness in our in understanding of mathematics, if I understand you correctly. So to what extent is your end goal of introducing this computational literacy at an early age constrained by the weakness in the education system in areas like maths? You can pick one language or many or particular kind of language. But
it's an excellent question, but that also brings me to an interesting question. Interesting question back to you. It's this. Do we base our curriculum, let's say I'm saying our programming, around scientific type of computing or more commercially centric? I'm just putting it out there. I'm actually asking a question, but it's, you're going to see where this is going, right? So I'm putting it out there because this is an important question. You know, are we training to work on SK and things like that, or are we looking to, you know, I'm saying depending on what type of curriculum we have. You know, I'm saying what's in it. Is it, yes, please?
If you look at that in general, general computing area thinking, pure computer science, where they develop new algorithms, the software engineering will actually apply that additional ability, and then your IT or information section, and then your IT or, as I say, in the information technology section. So those are three parts of the triangle. And there's been lots of literature what fits where. So if you want to very much, I'm talking about tertiary education, if you want to agree, if you say technical side, engage computer science, I believe it's not easy. Whereas actually doing the information side, you need more commercial type of applications. Whereas on the software engineering will be more to your engineering type of applications.
Exactly.
So like physics would be the basics for electrical engineering. Computer science is the basis of software engineering. It's more the theoretical. I think that, but there's lots of arguments in the literature about that.
So exactly. So that's a really good point. But now you bring it to the context of school, and you got calculating. So what is it? You see what I'm trying to say? Is it's in that particular perspective? What do you? Yeah.
I don't think it's a choice that needs to happen in school.
No.
You know, these are the fundamentals of what lived in both worlds. You apply the same tricks in both worlds.
The basics itself, the actual general underpinning. Yeah.
Science, not applied for.
Yeah.
That's it.
Then maybe on your point is, I also do believe is that when you find, like I mentioned, early childhood at least, when if we get to the point where you can actually teach them to build things using programming and that, I also do believe and I'm just putting it out there, this is not research, but I do believe it'll have a positive impact on other subjects as well. You know what I'm trying to say? So I'll give you an example. I'm 8 years old, and I'm like, I got a hold of something like a Raspberry Pi, and I figure out how to write a little game. And I'm like, first thing I encounter is some form of physics. You know what I mean? As I said, but no, again, what I'm trying to say, maybe not to some great depth, but enough for me to say, oh, okay, maybe I'm struggling with this. Why am I struggling? What's the math part? Yeah, you see what I'm trying? You see where I'm leaning towards this. There's nothing more encouraging than when there's a reason that you have to learn something. Yeah, I look at maths and I'm just like, I apologize to anybody who's on the math curriculum side, but the way I see it in the schools is it's a bunch of techniques. The first thing I encountered, like, if you look at university level, is you're like, oh my goodness, it's not just techniques. There's actually reasoning and deduction on these things. It's amazing. Where's that in school? And I think that can happen in these sorts of contexts. We actually have to try and computationally structure things and then say, well, what domain does this apply to? What skill do I need? You see, and that's why I believe this is, I think, one of the keys. But
to your point, somebody once said that if you want to understand something, really understand it, teach it to a computer, write the algorithm.
There we go. Okay. Good point. But we've run out of time. I don't want to keep everybody waiting, so I'd like to just quickly do a closing and do a quick welcome. So, 1 second. So just very quickly, what I wanted to say was that just to give you a big quick idea of where to from here. I've just got literally 2 sentences. The very quick thing is what we're going to do is we're going to have a very similar event in Johannesburg. I mean, that's where I'm at, so I'll run one over there. And we'll do one in Durban as well. Very similar event to this. Then the idea is to basically gather these suggestions and things that correlate, that seem to make more sense than anything else, and actually create a recommendation paper that we can put forward to the DB. I would like to, vouch for this, that I would, take this up the way, I did things last year where I will literally take out the printout and take it straight to the office and speak to the necessary parties over there that I have a decent relationship at the moment, so that it lands up in the right hands. Okay, so that's really the idea. And please, any comments maybe on that if you have 1 or 2 things. But that's really our idea on how we want to tackle this immediately from this particular point on. Okay. So, and then just a last, so you want to?
Yes, I want to thank people. So.
I'm thanking. Okay. I have to thank you, David.
Thank you.
Thanks. So, so yeah, that brings me really just to our thank you notes. I'd like to just give out some special thank you to our sponsors, IEEE Computer Society, the World Design Capital, and Rhenish Girls High School for the warm welcome, obviously, and the use of their facilities. And then just some final notes, and also on the sponsor side, last but not least, is Coreware Software for helping us organize this event and for the excellent support during this entire process. Okay, and then lastly, just maybe a thank you to all of you for being here and online viewers by the live stream as well. So. Thank you again.
Okay, thanks, Jonathan, for coming all the way down from Johannesburg. We appreciate it very much. So I'm sorry the bandwidth was a bit dodgy. I sent a rude tweet to Vodacom and it's improved miraculously all of a sudden. So that seems to have worked. We've got, in terms of the process forward, Alan has outlined a follow-up meeting in Johannesburg. There's more things to do on this sheet that we handed out. There's 2 more events of Design Capital that are planned. We've got a colloquium, software engineering colloquium planned. We're doing a book on software design. So anyone who would like to contribute to that is more than welcome. So once again, thank you, Alan, very much for coming down for Johannesburg. And there's coffee and there's muffins at the end. So if you wish to stay a few minutes more than welcome.